Roger once again, Mudfossil University, today with bacteria pooping gold. That's right, gold pooped right out of the little bacteria. They're just eating it and pooping gold, eating heavy toxic waste. Isn't that nice? I mean, well, how can you get better than that? Go out there, eat up all that stuff and poop me out a bunch of gold. That's what they're doing. So that's pretty good. Now, and I tell you what I'm going to do for you. In this video, you got to watch it though, because I'm going to tell you how to get healthy, or at least to understand what's happening in your body and how you can possibly get healthier. I never give any medical advice. However, during this video, I will give you advice on where to find gold. It's not hard to find. So I will tell you where to find it. This is what I do. I study the earth and I study the concentration of materials and how they concentrate and why they concentrate. And it's from the study of mud fossils. And it's a very, very scientific study. It's not something just looking at things as, oh, this must be this, must be that. No, it's much, much, much deeper. Now, so now that we know that bacteria can poop gold, well, what's that all about? How does that happen? This is the reason your body and you live and you thrive is because of bacteria. All right, let's just cut right to the chase. It's because of bacteria. If your bacteria in your body is not correct, you will be sick. And if your infant is not correct, that infant will be damaged for life. And I'm telling you this right now. It's irreversible, the neurological damages that can be affected by this biotin deficiency. And the biotin deficiency, all that is a way for the molecules that come into your body to be broken up enough to where you can use them. That is the key. That's the whole thing. That's everything. I just told you everything you have to know about being healthy. You can eat all kinds of stuff. And if you can't get it into the little bitty tiny packages which you need to be able to transfer in your blood to get to the places you need to be healthy, you're going to be sick. Case closed. I don't care what the doctor says. This is all my opinion. But I'm telling you right now, if you don't eat right and you don't have the correct bacteria in your gut and you don't have the correct enzymes which create the metals that do the carboxylation, you will be sick. I know it's a bunch of big words. They don't mean anything. All it means is you won't have enough ability to attach to little bitty pieces because they won't get broken up. The enzymes break all these things up. And where do the enzymes come from? They come from bacteria. And what do? We take antibiotics. And the kids get, I put out a post about this. I want to find out from women, did they give you any antibiotics? Did they give you any penicillin? Did they give you any of these kind of things? And yes. And what was your children like? All kinds of problems. And I'm telling you right now, I'm telling you right now. It's not, your body has to deal with the things that go into your body, and if it cannot deal with things that go into your body, they just leave or they collect. Either way, you're in trouble. And if your metals are not there to transfer these things, and the enzymes are not there to break these things into the small enough pieces for the metals to grab a hold of, then you're sick too. And the worst thing is this biotin, because it affects a lot of the fatty acids and things which are extremely required in your body. Fatty acids, very, very, very important. You always hear, oh, you need this fatty acid, that fatty acid. Well, that's true. But you need it in a way that it can work within your body. So we're going to go into all the articles I'm going to show you are all from the National Institute of Health and places like this. They're not something I'm making up. Now, this is from Live Science. So let me see. I don't know if I highlighted anything. I usually do that if something makes sense. Here. Oh, yeah. This is what This is what I want to talk about, because everything's about money. It doesn't matter about the health, or it doesn't mean anything. But listen to what they say down here. They go through all of this. They say this is very important. Now, understanding this process is very important, according to Nye and his colleagues. You know why? They can turn it into gold. Right now, the only way to do this, they say, it would be possible to take ore with a very low percentage of gold, transform the precious metal into a water-soluble version of itself, deposit the solvent from the rock, and then voila, everything's wonderful in life. You have a shiny gold piece of gold. Well, I'd rather have it in my body fixing it. Because it's supposed to be in your body. They used to give people shots for gold shots for arthritis and for joint conditions. They get away from all this stuff. You don't need any of this stuff. Well, let me tell you something. You need all of this stuff. Every single metal there is in the earth, I don't know, maybe mercury not, maybe aluminum not. Well, I know aluminum, yes, absolutely. In your skin, you need aluminum a lot, I think. Anyway, we don't have a database to know anything about what you have in your body. No database about what your blood is in its entirety, what metals are in there, what this and that's in there. What about your bacteria? No clue whatsoever. Now I'm going to go into something that makes a lot of sense to me. Totally non-invasive. Apparently the equipment is either not made yet or something, but it's been like 15 years they've been looking into this, and all kind of potential, and never did anything. Hold on a second. All right, here's what they did, and here's why I'm looking into this, because all they use is your exhaled breath, and they're looking at it for occupational respiratory medicine and hazards and stuff. What are you spitting out? You got mercury coming out of you or whatever, but they can take your breath and just breathe into like a frosty bag. It condenses in there. You wrap it up, you send it off, and they look through it. Now, they claim it's all real expensive and all this. Look, this breath analysis technique rapidly gaining ground as a non-invasive tool to diagnose and monitor various aspects of lung disease. Well, not only will it do lung disease, but it will do a lot of other diseases as well. They just don't understand it. They think it's strictly related to what comes out of your lungs, but what comes out of your lungs is carbonic acids, and there's like, I think there's like 3,500. They say 250. But measurement of exhaled breath is safe, rapid, simple, and effort independent. So you just do it. You just do it, and you give it to them, and if they go zip, they say, you're all right. Oops, well, wait a minute, you got this or that, and then they talk to you. Given that human breath contains upwards of 250 chemicals, way upwards, my friend, the potential for developing new applications is high. And I think they found at least 3,500. Because you're taking in all these chemicals, carbon dioxide and this and that and nitrogen, and all of these things are binding with other things, and they come out in these carbonic acids out of your lungs. And I think I know why, and I can show you right now. I've shown this a couple of times, but I'm going to show it again. And it is because the same process as works in catalytic converters with the platinum. Something attaches molecularly to allow the platinum to remove the chemistry, whether it's to grab a hold of some other molecule so it can stay there and get heated or whatnot. I'm not sure of the process, but my point being is that these are transition metals, and if you look at them real carefully, you'll see all little fracture looking things in them. They think these are shock cords. They're not shock cords. This is a lung of a little tiny creature cut in half. And I have lots and lots and lots of examples of this. And what happens is, I believe, as the blood comes through here, all that red looking rusty stuff comes by these crystals, which are literally the lobes of the little pockets in your lung. Somehow those pockets in your lung have either collected these transition metals, or they float around in there, or whatnot. But the transition metals are these little different colors, a little red and blue looking and orange and so forth, purple and that. Now, and some of them get spectacular colors. I mean, way more brilliant, because it's all transition metals. So, my feeling is, and this needs to be tested and checked out, but as the blood passes through this structure that contains these metals, they, as transition metals, they can attach and detach with a single electron. And I believe that's what they're doing. They're grabbing things out of the blood. Then, as you breathe in, something mixes with that and attaches to it off of this, because there must be some other lesser pH or whatever in the air, and at that point it attaches to what you just breathed in, and now it's going out with that next breath. And of course the opposite happens to the other crystals. They take in things. And I say that's why this has happened. It's all related to transition metals within your lung. Look at that. Look at the different colors. Look at the different crystals. Look at the different structures of them. That's like a filtration unit. It's a filtration unit. Something is grabbing, the red ones are grabbing something, the blue ones are grabbing something, the purple ones are grabbing, the orange are doing something else. And there is, like they say, 2,500 or 250 chemicals, excuse me, that they know about. And I'm telling you right now, they don't know about the vast majority of it. So that is the nature of your lungs, I believe. So why can't we get this test done? That's a very, very simple test. All right, that's basically starting at the end, because we need to be able to find out what is in our body, what chemistry is in our blood, what is in our fecal analysis, what bacteria lives in us. If we don't know those, you can't be healthy. I don't care what you say. You're going to go to the doctors, you're going to say, well, what do you feel like? Well, I don't feel too good. Well, try this, see what happens. That is the best he's going to do for you. I mean, he may say, well, you have a little of this in your blood and a little of that in your urine and a little of this, your eyes look a little that way, or your skin is a little red looking. Let me put a little salve on there or something like that. Yeah, okay, you might do that. But you got to get to where it's, what's your problem? Why is my skin so sore? Why is it always bloody and scratchy and peeling and have all these, and it's all over my body, or maybe it's just on my toes, or maybe it's just a fungus area, or maybe it's some, why are these happening? Can I tell what's going on in my body? No, you cannot. You can't. You can't say, well, what's in my blood? You say, I have no idea what's in your blood. You say, well, what's in my fecal analysis? Do I have enough bacteria to make the enzymes that make the transition metals that feed my body? No clue. But we can give you some that'll kill any that you do have. If you're not feeling good, take some of these. Maybe it'll kill everything in you, and then you'll feel better. I don't think so. Before you should be able to even take anything, you should know what are you doing? I mean, would you go to somebody and say, here, give me some additive for the oil for my car, I don't know what's wrong with it, just put something in there and see what happens? I wouldn't do that. So I'm just saying, it doesn't make sense. You got to have a database, and it's very, very, very simple. This would be one of the things you'd want to see. What is in a person's breath? It's going to fall into line with something. I absolutely, totally, 100% guarantee it. If I'm wrong, I will eat this keyboard right off the counter. There's no possibility that you will not get data back that will not have similarities of all kinds of natures. Occupations, that's what they're looking for here, occupational problems. What's this guy spitting out? Is it something that he took in from work, or is it something he's just spitting out naturally? They don't even know now. They really don't know. I'm telling you right now, they have no clue. Let them tell me that I'm wrong. Because I'm not wrong. They do not have an idea what the average human body presents as the norm. That I can't find it. If you could find it, and it exists in a database, and I could go there and say, what is my, whatever I want to find out, what kind of bacteria I have in my body, what's my percentage should be according to a person my age, my gender, my this, my that, all those things. And you can do that in a database, absolutely no problem. And all of a sudden you find out you're half of what everybody else is. Well, now you want to think about that. But why would you just grab something and start eating this and that, and no, and do that and this and that, and hope for the best? Not the way I ever did anything. Why aren't we using, listen to this. This is in the last decade, and that goes a decade ago. There's been increased application of exhaled breath analysis, either considering exhaled gases and exhaled condensates in pulmonary research. Okay, so they were looking at pulmonary research, but they just didn't go any further with it. See, exhaled breath analysis has enormous potential as an easy, non-invasive means of monitoring inflammation, oxidation, stress in the airways, particularly in non-disease subjects. exhaled air can be collected without the need of unpleasant stimulation of the airways as occur in sputum induction and lavage sampling. It goes on to say, in a sample of breath, more than 250 volatile substances can be identified just by gas chromatography. But interest in using exhaled gas in the investigation of pulmonary disease processes occurred relatively lately. And that was 15 years ago or something. Nitric oxide and carbon monoxide, volatile organic compounds, which is, there are like 3,500, which they don't understand the volatile organic compounds. Those are the things that you're expending from your body. Those are the things you got to get rid of, alcohols and acids and things like that. They're now being studied on a larger scale, whereas air containing exhaled volatile compounds has been examined for a long time. Exhaled breath condensate, EBC, obtained by cooling exhaled air under conditions of spontaneous breathing. All you got to do is spontaneous breathing. I'm sorry. All you got to do is take a plastic bag that's really cold and breathe into it spontaneously. All right. Where was I? Okay. By spontaneous breathing is a relatively unexplored biological medium that could provide an assessment of lung pathobiology. All you got to do is breathe into a plastic bag that's cold and send it to somebody. I mean, that's... EBC is a biological fluid mainly constituted by water, but also containing small droplets of airway lining fluid. You're just blowing air real hard into the bag. The interest in this is justified by the fact that its collection is totally non-invasive, does not cause any discomfort or risk to the examined subjects. And it takes about 2 seconds and it's almost free. Now, you would send that to somebody that would analyze it and then put it in a massive database. And say, these are the chemistry that's coming out of this guy. And he doesn't feel good. He's sick all the time, man. He's got scritches. His skin is itchy. His eyeballs are twisted, whatever it is. And then you'd go in there and you'd say, I'm 47 years old. I'm a white male. I want to know... I don't feel this, or I don't know, is there any, and then what's my chemistry like? I don't think this is not over the moon stuff here. All right, this is another one from Sciencing. It's called, and it's called The Chemical Composition of Exhaled Air from the Human Lungs. And it talks about, well, here it is right here. Some scientists suggest exhale contains more than 3,500 compounds. This is what we should know. What is in this guy's lungs? And then you'll know, is he sick or isn't he sick? Does he have some bacteria missing? Is there an enzyme missing that can't break down these molecules? Now I'm going to show you why the enzymes are key to this, and bacteria are key to the enzymes. And not killing bacteria in our gut is key to being alive. There's another one right here, Journal of Breath Research. Breath concentration, acetic acid vapor is elevated in patients with cystic fibrosis. What does that mean? I have no clue. You don't either. Neither does the doctor. All right, this is a lot of big words. All it boils down to is there's carboxylic acid reduces things down to ATP, which is the molecule, or it's actually a ion, a proton, that you use to live. And if you don't have ATP, if that stops production, I'm not kidding you, I think you got like 4 or 5 seconds to live. Case closed, you're done. And you wouldn't have any idea how much ATP you burn in one day. I'm going to tell you something. This will blow your mind. ATP is what you consume for energy, okay? And you use it, but you recycle it. Now, a long distance run, an ATP, you burn it just like anything burns with oxidation. O2, you're running, okay? So what are you doing? You're burning oxygen. You have consumed oxygen. How much oxygen do you think you could consume a long distance runner, if he runs a marathon or something, I think he uses a ton, an actual ton, 2,000 pounds of oxygen to do that. But you recycle this ATP. But if that ATP stops, and I mean like spontaneous combustion, you're done. You're dead. Anyway, going back to this, carboxylic acid it breaks down things very fast. If you don't have this, and it's only a few enzymes have been characterized to date. They don't know about it. See, only a few enzymes. Whereas the vast majority of these cars, they call them now, have yet to be examined. So, they're just clueless about the whole thing. And this is 2017, so this is not like a long time ago either. Herein, the authors report the 12 bacterial, there's just a bacteria. Bacteria causes these carboxylic acids that are the reductases. 12 bacteria reduces a broad range of bifunctional carbolic acids. All right, so they're saying these 12 reduce all these different types of acids and break them down. And that is the only thing they're supposed to do. These enzymes come out and they break down things. All right. Carbonic acid reductase. All right, so they have to break all these things down. Thus, our result illustrates the broad biochemical diversity of bacterial cars and their compatibility with other enzymes for applications in biocatabolism. Well, let's go see what that means. It's just because I looked into all these things. I'm just going to go down to I don't know what. Oh, here's this one here. Because I have them all opened up in Windows, but we'll just drop down through them and I'll talk about each one. This is a place, environmental alternatives. They talk about water, and absolutely correct. New filtration methods combines enzymes with bacteria. That's the filtration things in the water. They go out and they harvest up all these things in the water. And, using enzymes and bacteria, which is what we use in our body, exact same thing, enzymes and bacteria, they're both there at the same time, absolutely no question. As separate methods, they used to, for water filtrations is not new to the industry, but a combination of both is an innovation. It's just like the same thing in our body. And it goes on about using these and how wonderfully they work. And I believe that's a fact. I would talk to these people if you need some help in this area. They seem to be saying the things that I believe is correct. Using bacteria and enzymes separately has its disadvantages. An enzyme may break down sludge, tiny particles. And again, you're trying to break things down. You can't take them. You can't take a big rock and eat it and it's expected to do something for you. You got to break that thing into like its molecular tiny bits. What does this as an enzyme? It's a catalyst. It goes in and it says, all right, get out of there. It's like that guy that does all the fast chopping on it. And then you got little bits of stuff you can eat. But if he gives you the hunk of meat, just take a bite of that and eat it, or eat the whole thing in one bite. You can't do that. I cannot do that. You can't give me that thing, and I cannot eat that thing in one bite. So he goes, it's all right, now eat it. It's all right, no problem. And you're all set. You feel good, you go home. The other guy standing there looking at a big thing he can't put in his mouth, and he falls over dead because he starves. I'm telling you right now, or he chokes to death because he tries to eat it. That's exactly what's going on. Absolutely. But they have to creating the exact formulation of enzyme bacteria to ensure effective filtration is not a simple task. And we know how to do that inside of our body. I'm telling you right now, your body regulates itself better than any instrument ever been designed in anywhere. Various types of bacteria and enzymes are produced, and they mix them all together. And apparently they know what they're doing. I would talk to these people because they're as good as anybody I've seen, yeah. Using bacteria and enzymes as this. All right, anyway, so there you got your bacteria and your enzymes. Those guys know what they're talking about. Now, let's go back to the National Institute of Health. Now, listen to this. This is the killer. They're not putting these things together. They just don't understand. Histamine release induced by histone and related morphological changes in mast cells. Oh, that's interesting. That's pretty cool. What the hell is a histone? Histamines, we know what that is. You get all kind of reactions and allergies, and your throat locks up and you can fall over dead from that. You know, antihistamines, you have to take them to stop from flooding your system. Why do they do that? All right, I don't know. It's not. I don't see anything there that makes it, but it's all histone mixture. Amount of histamines released was reduced, adding CA2. Well, anyway, we don't know what that's about, but we know it's an issue. Now, what do we have here? Holocarbolase synthase. This is the only takeaway. This enzyme is important. Enzyme. Enzyme is important for the effective use of biotin. Biotin. If you don't have biotin, there's nothing that's going to grab onto anything. It's like glue. All right, a B vitamin found in foods such as liver, egg yolks, and milk. I don't know. It's a molecule. Let me put that, biotin. All right. And then it talks about many of the body's tissues, hydrocarbolase activates other specific enzymes, more specific enzymes. I don't think they understand what's going on. I really honestly don't. They say, oh, it makes this happen and that happen. That. Well, who knows if they're right. But I think they got to get to the beginning of this and understand how the whole thing happens. It's bacteria, it creates the enzymes, it creates the transition metals. The transition metals have to be in your body to transport things. The enzymes have to be in there to cut the things up to transport them. I don't see any big issue here. And it's all related to your bacteria or the enzymes. And if you don't know what you have in your blood, you don't know what your body did to make the things that went into your blood, so you have no clue what the bacteria is, you don't know what the enzymes are, you have no clue what the fecal material is that's in your body, you just don't have a clue about your body. You have no idea what you're breathing out, because you may not have a problem in your lungs. I mean, in your blood and all that stuff. But you may have some kind of issue going on, some kind of infection of some sort. But I think all of that stuff will show up. Any kind of an infection, because every infected tissue is going to give off a different signature. They're not going to just all give out the same signature. I'll show you why. I'll show you why I say that. All right, this is an opalized heart. This is a heart that was petrified in blood, and these are the transition metals that occur in blood, and all these little red and blue, green and purple and blue and all these orange and these different turquoise colors, those are transition metals. Now, the reason I say that everything has its own signature is that if the chemistry of this and these little strings that come down, I think they're called the heart strings, I guarantee you is different than the chemistry of this brown area, or the chemistry of the red, or the chemistry of the green, or the chemistry of the blue, or the chemistry of the orange, or the chemistry of the pink, or the chemistry of the magenta. All right, and there is every color you can think of in here. If you look carefully, there is colors that are very, very specific in very, very specific regions. You see that? You see that over there? You see that? They didn't just happen to come this way by accident. This stuff here and this stuff here is of the same nature. Right? These metals here and these metals that are floating in the blood here, these are of the same nature. Right? These metals that are impregnated into this cardiac muscle are of the same nature. These are transition metals. Right? They move through your body, and what they have the ability to do, and I think I showed in the little lungs that I have here, because in the lungs is where that exchange of gases happens and all of that stuff, and they have the same colors as this. These weren't petrified in the same manner, however, in the same conditions. But as this blood with all these metals in it is circulated through your body, into your lungs, as you breathe in oxygen, or in everything that's in the air, whatever it is, nitrogen mostly, and oxygen and all that business, wherever you are, you've got carbon dioxide, whatever's in the air is going to come into your lungs. All right, so you suck in a whole bunch of air, and what happens is these transition metals have what's called a single electron ligand. All right, doesn't mean the words don't mean anything. Don't worry about that. It's one electron can say, here, I'm going to clip onto you, and I'm going to hold on to you. But if somebody comes in there, I'm going to go with you right now. So you'll take one of these here, and they'll say, I'm going to clip onto you, whatever it is, some kind of acid or alcohol or whatever it is in your body. You know how you breathe out alcohol. You can smell it. Everybody's done that, smelled that. So let's say it's alcohol. Click. He says, okay, you're going to come with me. I got to get you out of here, man. This guy is going to fall over. So it goes out through and it gets over into the lungs. And then in the lungs, it says, well, what are you doing over here? He said, well, the guy's going to get, he says, he's going to fall, man. You got to get this thing out of here. And he said, all right, well, let me see if I can get a guy coming in here in a second. And it says, hey, you over there, take this one and give me that oxygen. And it's okay, no problems. He gives him the oxygen, he gives him the alcohol. Out it goes. The oxygen goes down to try to revive the guy. That's how it works. And it happens with every chemical. Now, how does it just blow that stuff out of your body? How does it get, why would it just decide to leave? Well, my expectation now, after long and many hours of study, is that these babies, right here, these crystals, these molecules that are in and amongst this red blood at one time, are transferring from, these are the metals. These are the metals where they're embedded in those tissue crystals. And those are the things that are transferring, just like they do with the catalytic converters, with the metal on the catalytic converters allows it to either overheat and expand it, or however it does it. It takes rid of one of the molecules there. So this is my expectation, that all of these things are related together, and we have to know what is what's in your body. Do you have any of the green stuff? Maybe you don't even have any of the green stuff in you. What if you didn't have that? What would happen? I don't know. We don't have it in a database. There's actually, you might even be able to, I always thought that this was possible, is to be able to take a fluoroscope in through the body. The guy's got a problem with his heart, it's whatever the problem is. He comes up in here and he looks and he sees, ooh, that's not the right color. The thing's orange, it's supposed to be blue. Alright, so what would that mean? And it means something, because you can actually tell by the color what metals are missing, and I'll show you. No, you saw the colors that are in that heart. Here you go. You mix a little of this, mix a little of that, it's going to change the color. Now, whatever the tissue itself is made of, it specifically wants these specific molecules in these specific colors. So that tells me that that tissue is highly specialized. And it requires these exact mixtures of metals and things. I mean, that's pretty specific chemistry. That is tricky stuff to do. How does it get exactly the right thing to those exactly correct places? All right, the tissue itself is asking for something there. So if you cannot provide that with its requirement, you're going to be sick. That's just as simple as that. And these are the things that are made by the enzymes. These are the transition metals that the enzymes collect, like the gold poop, and they go into the body. Now, they have to go into the body in a very soluble form, which means they can go into the waters of your body, into the liquid that runs through your body. Very soluble. It can float around, which means it's very finely broken up. Hello. All right. So now that you know the colors and how they affect tissues, it's pretty obvious that, and this is all about carboxylation and metal. See the metal, it's sequestered in the center and it holds onto these molecules. They leave, it comes back, it grabs another one. It depends on the pH. You have a certain pH in your lungs, and then you have a certain pH in your extremities. It gets down there and it dumps it at that different pH, and it picks up at that different pH. All right, this is pretty important. I'm going to have to read this more than I normally would. This is HLCS, which is holocarbylase synthase. It's biotin. Think of it this way, and biotin is an enzyme. Now, and it talks about making ATP and the ligands and all this. In is a human gene that produces, and they talk about the human gene that produces this, that provides instructions for making an enzyme. Right? That's what they say, called that HLSCS. This enzyme is important for the effective use of biotin, and biotin is the thing that attaches to all of your different molecules to carry them around your body. It's like glue, and it's found in these different foods. In many of the body's tissues, this synthesis activates other specific enzymes. So there's more enzymes that go in and they chop up a bunch of more little things called biotin dependent. So attaching biotin to them. So that's how the biotin attaches. I mean, it's just so simple. These carboxylase are involved in many critical cellular functions. That means they deliver and pick up, right? Including the production and breakdown of proteins, fats, and carbohydrates. When they say they produce them and break them down, they're chopping them up into little bitty pieces so that they can be absorbed, put into the solubility of the system. Otherwise, you cannot absorb them. I don't care how much you got of them. They can produce all they want. If they don't cut them up, you're done. And they're hard to cut up. They don't cut up unless you have the enzymes. Then you become malnourished of certain things depending upon which enzyme is missing. It's as simple as that. This same thing may also play a role in regulating the activity of genes. Now they say it's because of the genes. I'm not specifically going to buy that without a little more research. In the nucleus, the enzyme likely attaches biotin molecules to histones. Well. What the hell is a histone? You ever hear of allergic reactions? That's what we got right here. Now, let's go back to there. In the nucleus, the enzyme we're talking about likely attaches biotin molecules to histones, which are structural proteins that bind to DNA and give chromosomes their shapes. And they also give people allergic reactions. Changing the shape of histones may help determine whether certain genes are turned on or off. However, it is not known how adding biotin affects gene regulation. There's a lot of work to do here. So now we're talking about biotin and histones. Now what do we got here? Glucogenesis. There's nothing to take away from this other than that it is from breakdown of proteins. You have to break things down. You cannot eat giant things. All right? Fatty acid synthesis. Same. Through the action of enzymes. Fatty acid is the creation of fatty acids so that you can use them through the action of enzymes called fatty acid synthesis. Right? The process takes place in the cells. All right, now, what else we got here? Catabolism. The breakdown of complex molecules, which you just ate, in a living organism to form simpler ones, together with the release of energy. We get the energy when it's broken down and the energy is released in us. It's a destructive metabolism. We eat, that's just catabolism. We're eating these things up. Break down molecules into smaller units that are either oxidized to release energy or used in other anabolic reactions. Alright, so we're getting an idea of how the body chemistry is working here. What is this? An enzyme. Whoa, this is the thing we've been talking about. Here it is. What the hell is an enzyme? Let's talk about that. Enzymes are macromolecular biological catalysts. Whoa. Macromolecular, gigantic molecules. There's no, let's talk about water. Water is H2O. That's one of the smallest molecules there is. All right, it's 2 hydrogens and 1 oxygen, very small. These things are just thousands and thousands and thousands of atomic attachments in one molecule. So They're macro, gigantic, biological. They're in people. They're made by people. And their catalyst means they're sitting there just waiting to attack something. All right, the enzymes accelerate chemical reactions. The guy comes over, he says, hey, you got any of this? And the guy says, yeah, I got a little. And this cuts it off. All right. So if you don't have these, they'll sit there and they'll bargain for a while. Say, well, what are you going to do for that? And the guy says, I'm getting tired, man. And finally, you'll just fall over dead. This guy, you got to have him. He cuts things up. All right. So if you don't have the enzymes, forget about it. You're in trouble. And the enzymes come from the bacteria, we know. And the bacteria come from having a healthy gut. We know that too. So the molecules upon which enzymes may act are called substrates. Well, that's just like because they're sitting on top of them. And the enzyme converts the substrates into different molecules known as products. Wow, that's amazing, products, exactly. They break them down into little bitty things. Almost all metabolic processes in the cell need enzyme catalysts. You see that? Every one needs these enzymes, almost every process. How is this missed so much? In order to occur at rates fast enough to sustain life. These things are, spontaneous combustion. Done. So you want to see a cell, what do they call it? Oh boy, I can't remember. It'll come to me. Whoops, hold on. It's some kind of gene, it splits the gene right in half. I can't remember the name, but anyway, these things work so fast. They work faster than a jet engine, than a jet plane travels, and that's in your body. And these microchips, done so fast you have no clue it's done. And splitting cells and things are very, very, very fast. So we know we need these things, these enzymes, and every process, almost all metabolic. And what does metabolic mean? It means life. Everything you need in life in the cell needs enzymes, catalysts, in order to go fast enough to keep you alive. Metabolic pathways depend upon enzymes to catalyze individual steps. Boom, 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 and it gets to the end, and now it's done its job. So there's not just metabolic pathways. Doesn't mean, okay, come here, you're all done, have a nice day. No, come here, you got to go down and see the guy down on block 7, and he's going to give you something to take over to the guy up there, and he's going to add another one of these to you. Don't worry about it, you'll be all right. And the guy will just make his way down through the pathway of the metabolic pathways, adding and subtracting upon enzymes to catalyze individual steps. The study of enzymes is called enzymology, and a new field of pseudo-enzyme analysis. Why is that pseudo? I hate that freaking name. Pseudo-enzyme analysis. Recently grown up, recognizing that during evolution, some enzymes have lost the ability to carry out biological catalysts. No, they didn't. They're dead. Which is often reflected in their amino acid sequence and unusual pseudo-catalytic properties. They just don't have the right stuff to make them real. That's why they're pseudo. I hate that word. I really, really hate that word. Enzymes are known to catalyze more than 5,000 biochemical reaction types. That's 5,000, and I guarantee you they are so far more than this. They have no clue whatsoever. Most enzymes are proteins, although a few are catalytic RNA molecules. The later are called ribosomes. Enzyme specifically comes from their unique three-dimensional structure. They come out and they go blah, 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 they roll all, and they are rolled up in these sequences. It's absolutely amazing. And my feeling is, let me put it this way. Every one of these molecules has an address. It literally has an address. It's called sacred geometry, so sacred numbers. If you took all of the angles, which the bond angles are precise, quantum is precise, and if you took all of those bond angles and added them up in every molecule and called that an address, you would be able to address anything in your body through the system of numerical addresses, exactly identical to what is used in a computer right now. You have codes and addresses. They address places, and when they get to the address of the place, they dispense the code. Somehow we are communicating with our bodies. There is a and that is the way computers communicate, and they handshake. They send down a signal, and they actually get a response to say, all right, I got what you told me to do. In a computer, it does. You know, it sends down, like, let's say it sent down Enzyme to another computer. It sends it out, and it says this is a 1, a 7, a 9, 11, 12, 16. It adds up all the numbers and makes it into a number, which is, what do they call it? I forget now. It's been a while since I did this. Well, it's it adds up to a number that gives it an address. It gives it a verification code. Call it that. I can't remember the name of it now. But anyway, they add up all the numbers, and they say, I'm going to send you this. And when you add up all the numbers, you're going to have 87. If you have the 87, send it back to me, and I'll know you got the right thing. Otherwise, I'll send it to you again. That's how your computer works. Because sometimes it doesn't get the right stuff. It has to try 3, 4, 5 times, depending upon how the wiring is or whatever it is. Or the traffic. Actually, traffic will break into these things, and they'll have to resend. Boy, this is killing me. I can't remember this. Hold on. Check digit verification. Check digit verification. And you'd always get these hex codes back. Anyway, there's something going on in the body that communicates with everything. I can guarantee you that. This doesn't happen by accident. Who the hell would ever think this? Oh, I bumped into this today and I turned into energy? No, absolutely not. There is so much complexity in the human body. To think of dead dust just globbed together and ended up in this magnificence is absolutely, literally insane. I mean, doesn't have any sense to it whatsoever. The dead dust would have to be the smartest dead dust that was ever created. Or not created, because it wasn't created, because it came from a big bang where there was nothing to create from. I think we got to take a look at everything else, right from the start. All right, here we come back to another one. Holocarbolase synthase. Once again, this gene encodes an enzyme, catalyzes the binding of biotin to carbolic and histones. There's your antihistamines. This is allergies. This is a very, very serious situation. I never had an idea about it, and I don't think anybody really does, because they don't. The only reason I know about it is because I studied the mud fossils, and they actually have the chemistry of the human body. And I started seeing this and that, and I started looking at the chemistry of the human body, and I said, whoa, we got problems. And we do. And this is baby's first test. I did this, Babies in Peril. I put this up a day or so ago. And 0 down thumbs. So there's a lot. Why take the chance on the kids to look into this? Somebody should look into this. Talk to your doctors. If you're a doctor, if you're in the medical area, I'm not being silly. If you can come up with a reason that, to just dismiss me and just say that, oh, you're being a silly guy, this is crazy, oh, you're going to make people worry about every little thing. Well, they might worry about every little thing. I can't help that. But I'm telling you one thing right now, the things that I'm showing you are not silly. And if you go here and you learn about carboxylation as well as I have, you will find out it is not silly whatsoever. These are fatty acid disorders. And they are for babies. The babies are the ones that are suffering from this. They have no clue what's going on, and they're being hurt from this. And it says these infants are likely, well, here, let me go back. Let's read it again. Well, let's read it from the top. This is very important. All right, these are disorders, fatty acid oxidation disorders. Multiple deficiencies. I'm not going to read all these big names again. Every time you see all these big fancy names, just remember it's an enzyme that they're missing. Okay, multiple enzyme deficiencies. Multiple enzyme deficiency is caused by defects in the incorporation of water-soluble B-complex vitamin. Well, they're talking about, in this particular case, biotin, I believe. We have biotin into or it's released from 4 places, and then it goes down all this. It's a deficiency. Let me put it that way. It's an enzyme deficiency. Case closed. I don't care how they characterize it. And now, frequent causes syndromes, alopecia, skin rash, encephalopathy, and actually death. Now, clinical course, biotinase deficiency usually presents in infancy, because if something happened to that mother, I got a feeling they gave her antibiotics or penicillin or something, and the baby did not have the correct chemistry in its digestive system, and immediately, as soon as they hit the oxygen, they're in trouble. And they get this dermatitis, resembles all these different things, patchy, alopecia, neurological features, ataxia, neurosensory deficiencies, developmental delay, convulsions, and a little later, the presentation, predominantly neurological symptoms, is possible. Biotinase later, in other words, if they didn't pick it up right away, so it'll pop up because they're slowly starving, literally, of what they need to keep their body healthy. You know, they'll say, oh, they're giving plenty of this, plenty of that. Well, they can't use it. It's too big. The molecules aren't small enough. And it's not because they're babies, it's because they're not breaking them down. So then what they do is a biotin assay is now part of a newborn baby screening program and frequently identifies infants with partial deficiencies. A partial deficiency is still a deficiency. That means if you don't have the right amount and the right type in your gut, you're going to be sick. I don't care what they say. These infants are likely to remain well, but late onset symptoms have been reported, obviously. And they will be unless the mother's milk and the, oh boy, somebody sent me something on it, cholesterol, creates the bacteria that it starts the gut working again. That's the key. Once they have this, you're in trouble unless you can flood it with the right stuff. And it says the deficiency usually causes earlier and more severe disease. Ketoacidosis, alopecia, red and scaly total body eruptions, coma, apnea, death often ensues if therapy is not begun promptly. This is serious. I mean, it's not, and now on top of that, these conditions, once they start to present, they cannot be reversed. In both conditions, the rash may be complicated by superinfection with monolia. There is sufficient overlap time and severity on onset. However, accurate differentiation between the two can only be made by enzyme analysis, enzyme assay. I can't believe that they're not being tested for this. It just does not make sense. They wait until the kid gets sick, then they say, okay, you don't have the right kind of enzymes. Oh, whoops. Why can't we test for these things when they're born? And why can't we test for them when they're young? And why can't we test for them going forward? And why can't we create a database of these blood samples and these fecal samples and these conditions? No names attached. You don't have to have the names. We need a database of how the human race is affected by these enzymes and your bacteria and your blood, what is in them and what isn't in them. It's as simple as that. I have no way to tell my wife, you don't feel well. Well, I'm sorry. Try this, try that, and that's what your doctor does. They can say anything they want. Oh yeah, we got all the tests for this, we got all the tests for that. Well, I don't believe the test because what they're doing is they're just guessing, and they're giving them something, and a lot of times they're giving them something with esters in there, which is like mineral oils, and the mineral oil is the only thing that's helping them, as far as I can tell. And that is good. I'm telling you, take castor oil. It's very, very, very good for you. And put it on anything I'm not going to tell you anything I don't have any medical credibility. I can't tell you to do anything, but I can tell you what I do for me. I put it on my joints when I get sore and stiff, and I had a shoulder operation, and when I put it on that, it helps. It helps me. All right, anyway, I think that if we don't have a a database on this stuff. It is really, it's nothing we're ever going to be able to do to be healthy, ever. It's just going to be go back and try this, go back and try this. Your skin conditions will never get better, and you'll have Alzheimer's probably, and kids might get, all the different things they're getting now, allergy problems, and all these different diseases that they're saying they can't sit down, they got to run around in circles, they got to do this, they got to do that. Well, their chemistry is so screwed up, they're lucky to be able to stand up, half of them. And they've gone in and they took the kids with autism, and they looked at their bacteria. There's a guy doing it, and I tried to contact him. I never got anything back. But he claims that there's only out of 1,000 normal bacteria that's in normal people, they only have 600 out of 1,000, something like that, at least in that area. But anyway, this is a problem that has a solution, and it's not being taken serious. Or I don't know if it's being taken serious or not, but it doesn't look like it to me. This goes back a ways. We're going back a couple of years now, and I have seen nothing. They might be talking about it somewhere, but when I ask people online, they're not hearing about that. Anyway, this is all carboxyl. It's all carboxylation. And it's all to do with the metal complexes. If you don't have those, you're going to be sick. All right? Mudfossil University, I hope this helps somebody.